Okay, here's another example, finding equations from given zeros. And you have to remember this, and we talked about this in class. Complex imaginary roots, complex numbers with an imaginary part, that is. So we call those complex imaginary numbers. So complex imaginary roots, zeros, remember roots and zeros are the same thing, always come in conjugate pairs. In other words, if a plus bi, remember this is our form of a complex number with the imaginary part being b. So if a plus bi is a root, then a minus bi is also a root. Or a zero, something that will make the value of the equation zero. Okay? So lots of times you're going to be just given one of these conjugates, and then you'll have to kind of fill in the other one because you should know that the roots come in conjugate pairs. So here's an example. We know that 0, or we're given that the 0, -4, and 7i are roots. We want to find the equation. Okay? So if 7i is a root, or a 0, then its conjugate is. So we also know that. So -7i is also a 0. Or root. Remember, these terms are just synonymous, root and 0. Okay? Is that all right? So now we have 4 possibilities. So when we write our p of x in factored form, this is in factored form I should write. So what we have is p of x equals, and then x minus 0, x minus 0, times x minus -4, which would be x plus 4, and then times x minus 7i, and then x minus 7i would be x plus 7i. So this is what we've got. Okay? And again, we've done this before. If we see x minus 0, we'll just write that as x times x plus 4. Oops. Plus 4. And then we're going to multiply this out in using our FOIL process. So x times x is x squared. X times 7i is positive 7ix. And then negative 7i times x is also, well, it's negative 7ix. So those are like terms. And then a positive times a negative, a negative times a positive is a negative. 7 times 7 is 49. And I times I is I squared. Now, we also have to remember that I squared is -1. We learned that when we talked about complex numbers, so remember that I squared is -1. And these are all always equal to 0 because these are equations, so that's equal to 0. So I guess I better write that down over here. Remember, I squared equals -1. Okay, so let me rewrite this over here. Hope you can see all that. Sometimes I get off center here. To look at my monitor a little bit more. So you got x times x plus 4. And then let's simplify this guy over here a little bit. So we got x squared. And then what's positive 7ix minus 7ix? Well, these are exactly the same letters except different signs, so that's going to be 0. And then I've got negative 49. And I squared, and remember I squared is -1. So I'm going to write this out. Sometimes you can take a shortcut on this one, but this time I'll just write this out. So now we've got x times x plus 4. And then that's going to be times, and then a negative times a negative is positive, so that's going to be x squared plus 49. Now that isn't too bad now because we've got a nice binomial here, which is relatively easy to multiply out. So now we've got x still. Again, these are still equal to 0, pardon me. Now we've got x, and then x times x squared is x to the third. And then x times 49 is plus 49x. And then 4 times x squared is positive 4x squared. And then 4 times 49, 49 and 49 is 98, and 98 times 98 is, I'm sorry, 49 plus 49 is what? That's, yeah, 98, and 98 plus 98 is 196, all right? Double check that. 4 times 9 is 36, carrier 3, 16, 17, 89. Yep, double check that arithmetic. Okay, and we got a parentheses there. Okay, and then we can multiply everything by x. And just add 1 to each exponent, so this is going to be x to the 4th. Oops, I should write this in descending power first of all. Let me do that, so I'll do that step by step. So I'll just leave that x there, get out my trusty whiteout. Okay, there we go. I normally use pencil, but I use ink so it's easier to see. So I've got x, and then I'll write this in descending power. X to the 3rd plus 4x squared, okay, plus 49x plus 196, and then I'll multiply out. So I've got, and I just add 1 to each exponent, so I get x to the 4th plus 4x cubed plus 49x squared plus 196x, and that's equal to 0. And then there's your equation with those roots. Okay. So it wasn't too bad. Again, it's the multiplication, and just got to be careful. And yet, again, you have to remember that, again, two things: your complex imaginary roots, or zeros, always come in conjugate pairs, and then I squared is -1. You have to remember those two facts when you're dealing with these complex numbers, or complex imaginary numbers, I should say. Okay, hope that makes sense.